Hello, I'm going to talk you through question 8 from the problem solving homework. So, we're going to begin with our non-uniform beam PQ being supported by R and S. Now, the beam is non-uniform, so we've got a force of 400 newtons acting down, but this is off-centre. And I'm going to label this distance x, because that's going to come in useful later for part I. Now, a buoy of weight 500 newtons can just stand at end P. Now, significantly, the question says just stand. So that means this reaction force here is reduced to 0 because the board is about to tip. So what we're going to do, part I, is find the position.
We've still got a reaction force at R. We don't know it.
But we've still got a reaction. Yeah, sorry, we've got a reaction force at R, but we don't know what it is. What we're going to do is we want to find, for part I, find the position of the centre of mass of the beam.
We're given some distances in the question.
We know that beam PQ is of length 4 metres, and we know that P to R is 1 metre and S to Q is 1 metre. So in effect, from question I, we can find distance x and we can add 1 to it to get our solution. So we're going to take moments about the point R, and we have, going clockwise, we have 400 x, and then anti-clockwise is equal to 500 times 1. So that's the force of the buoy times distance, and that's the force of the plank acting down times distance x. Solving, we get x is equal to 0.8 metres. And don't forget to add the 1, because it asks, the question asks, find the position. Just
talk me through that how you found x then again, Mr. Ricketts?
So divide both sides by 400, so you get x equals, oh sorry, I made a mistake, 1.25, sorry. 500 divided by 400, so you get x equals 1.25 metres. And then because it says find the position of the force acting down, we can say that the force acting down is 2.25 metres, because x is 1.25 plus this 1 from P. There's your answer to part I. Okay, part II. The boy walks towards Q. Find his distance from Q when the beam is about to tip. Now, clearly, as the boy walks over to Q, it's not going to tip when he's between R and S. It's going to tip when he is somewhere over here. So I'm going to redraw this diagram. Have the boy somewhere over here. And we know that this distance here is 0.75. And this distance here.
Why is that distance 0.75?
Because the force acting down is 2.25 metres from P. So this distance to Q must be 1.75 metres, which means that this distance here must be 0.75 metres. Now, this reaction force, because we know we want to find out where the buoy is when this plank is about to tip, we can again assume that this reaction force is going to be 0, and this reaction force is unknown, but isn't going to feature in the question. We know that the weight of the plank is 400 newtons, so we have 400 newtons, taking moments about S, we have the weight of the buoy. So the weight of the buoy is 500 newtons. And we're going to find out how far he is from S, so I'm going to call that Y. So taking moments about S, we have 500 newtons times y is equal to, then take a moment anti-clockwise, 400 times 0.75, which is going to give me 300. Then solving, we're going to get y is equal to 300 over 500, 0.6. So we found out that this distance here is 0.6 metres. But the question, find the distance from Q when the buoy is about to tip. The distance from Q is the leftover distance. So you have to do 1 minus 0.6 metres, which is equal to 0.4 metres.